So let's see. Module 1. Differentiate between the following terms, ROM and RAM. Okay, ROM is read-only memory used for permanent storage. RAM is random access memory used for temporary storage. For temporary. We got the black market. This is as black market as I've seen a paper in a long time. Like they scan it on a white page and just they take the picture and then they drop the picture on a page and then created a PDF. There's high level black market stuff here. I think there's the one that appeared in my inbox and people were sending it all over. But yeah, if you find any people looking slanted or leaning to the right or whatnot, yeah, whoever do the scanning of this, I mean, thanks, sir. But I just saying, watch your front page. Watch, man. Could I line it up properly first, though? Anyhow, there we go. Right, so that's RAM and ROM. That's cake. Surge protector and voltage regulator. Surge protector absorbs unwanted spikes in voltages, and voltage regulator maintains a set voltage feed to devices. Yeah, something so. Oh well, yeah. It's 2 marks. You're really trying to give them an essay. Supercomputer, microcomputer, supercomputer. These are CSEC questions, by the way. These are, I would consider these to be CSEC questions. Supercomputer used for complex calculations. Microcomputer used for day-to-day computing tasks. And now that we've gotten through that bout of diabetes, a gamer wishes to purchase a new computer. State 3 hardware specifications that should be considered and explain each one as chosen. Oh, look at that. 6 marks. Nice. Let's go with CPU speed. Because the game would have large amounts of calculations, the CPU should be fast enough, or else the game would stick. Next one will be RAM, because let's call this thing, man. The game may have large files that need to be accessed regularly. Large RAM would make it easy to access. And then what are the specifications? You want a big hard drive? That's totally not me owning it. That's totally not me owning. Yeah, hard disk drive. Because the game would have many assets to load, the hard drive should be big enough to store those assets. You're right. All right, so it says hardware specifications. So when it comes to hardware specifications, you're talking about CPU, RAM, hard disk drive, and you might want to have I/O ports, input/output ports like USB ports. You might want to have Ethernet for networking speed. Input/output ports, Ethernet speed, and you want to have connectivity. You might want to say Bluetooth for like a controller. Yeah. I can't see them accepting keyboard and mouse as a hardware specification because there really no specification inside a keyboard and a mouse besides like, you know, refresh rate or some kind of thing like that. They definitely, when they say hardware specifications, they're looking at CPU, RAM, and hard drive. You could fight I/O ports, USB ports, and connectivity. You could get Ethernet because that's a hardware specification. Once you could give some sort of speed for it or some sort of measurement of how good it is, that'll be good. Bluetooth would be okay too. Well, Bluetooth is a stretch. I would say. Yeah. Maintainability and storage, nah, I don't think so. Specialization. Screen resolution, yeah, screen resolution. Screen resolution is definitely something you look for. GPU is a thing. You need a graphics card. I'm just not sure if GPU on the syllabus, but if you put GPU, they can't give it wrong because you need a graphics card. So, yeah, let me just leave it at that. You have all these things. Once you could explain all of these here efficiently, it should be good. But I don't really see them getting too mad up once you can explain it. But that's some things you can't justify, like a keyboard and a mouse. If you say the keyboard and the mouse have like using a mechanical keyboard or using a mouse that has high sensitivity or some kind of thing, maybe. But I know these examiners and they're just looking at our exam sheet. They're looking at the answer sheet, and that answer sheet will have CPU, RAM, and hard disk drive. Positive, those will be the first three. You might get cache, because if you have a higher amount of cache, you'll be able to process faster. So you could put that. Word size will be like 64-bit or 32-bit. I wouldn't write that down. That's kind of out of the way of this question, but hey, you could try. Briefly describe the process of the fetch, decode, execute cycle. Okay, fetch gets the instruction from and puts it in the CPU. Decode, the CU decodes the opcode and operands, executes, the ALU does the calculations and stores it in a register or memory. Boom, 3 marks. Ooh, that was number 1. Jeez. Cotton candy in here, boy. The first 6 marks is a CSEC question. Part B is a CSEC question also, because hardware specifications inside CSEC. Only fetch, decode, execute, that's on the actual comp sci syllabus. Yes, okay, cool. I see diabetes in your future. Explain what is term multiplexer. A circuit that takes multiple inputs and routes them to a single output based on the state of a selection switch of, a selection, SELECTION switch or switches. All right. Construct the truth table for the circuit shown. Hey, this is the same thing I did on the Sunday Night Live. Must be nice. Look, they put the letters for you too. How cute is that? 6 marks. Let's go. A and B. Yeah, possible inputs are 0, 0, 0, 1, 1, 0, 1, 1. So we have C. All right, C is the not of A. So this is, I'll put any C on top here, which is essentially not A. Not A will be 1, 1, 0, 0. Then there is D. D is essentially not B. So not B will be 1, 0, 1, 0. Cool. And then there is E now, which is going to be the OR of the C and the B. Okay, so E, which will be not A or B. Not A or B, right? 0 or 1 is 1. 1 or 1 is 1. 0 or 0 is 0. 0 or 1 is 1. Am I correct? Not A or B, right? Not A or B. Not A or B. Yeah, cool. Nice. So that'll give us the E. Then from the E, we move on to F, which is A or not B. A or not B, correct. A or not B. So 0 or 1 is 1. 0 or 0 will be 0. 1 or 1 will be 1. 1 or 0 will be 1. Let's say that one more time. A, all right, 0 or 1, 0 or 0, 1 or 1, 1 or 0, right? Cool. And then the output will be AND of those two. Okay. So that is E and F, which is these two here. 1 and 1, 1. 1 and 0, 0. 0 and 1, 0. 1 and 1, 1. These are exclusive or X and. These are exclusive and. Yeah, I think these are X and. 6 marks. 1, 2, 3, 4, 5. Yeah. I don't know the 6 marks will get mixed up here, but yeah. We'll take it. We'll take it. And we go. Calculate the binary floating point representation of the decimal number 5.50 using our 1-bit scientific exponent. Alright, so we have 5.5, 5.50, 5.5, alright, good. So 5 is 101, 0.5 is 0.1. Yeah, 1, right? Yeah, cool. And then we have to take this and carry the point back 1, 2, 3. So that means the exponent is equal to 3. The exponent in binary will be 0, 1, 1. The mantissa is 101. 1. Hold on. I'm hitting myself. Yeah. Because a 5-bit mantissa, so you have to drop a 0 in front of that. No, you can't do that. I'm glitching right now. That was 0 there. Right. So I'll put a 0 at the end there. Right, cool. So then, as a positive number, positive means 1. Ta-da-da! So therefore your answer is 1, 0, 1, 1, 1, 0, 1, 1, 0. The exponent is 3. Because you have to move back 3 spaces. 3 spaces, which will be 1, 2, 3. Yeah. Alright, if we were to work it back the opposite direction, you'll be like, alright, cool, the mantissa is 1, 0, 1, 1, 0. The exponent is 3, that'll go 1, 2, 3. You'll get 101, 0.10. 101 is 5, and the 0.1 will give you a 5, and that'll be 0. Because that's a half. Positive is 0, yeah, correct, yeah, my bad. Yeah, so 0. Right, so this is the answer here. Cha-ching! Yeah. For some reason, like all of the mantissa questions will be 5.5. I don't know why they can't give it like, 4.5 or 6.5 or 9.5 or something like that. Because every year just be the same 5 mark thing. This is a half on the other side here. 0.5. Yeah. Cool. Right. No recap. Find the 8-bit 2's complement of -11. Alright. 2's complement. What's that? If you put the 0 before the mantissa. Oh. Oh, that's how I'm saying. If you put the 0 in front here, then the exponent would be 4. I feel they put a 0 here for a reason. Because it's to put the 0 to the end, they probably want you to account for that 0. That's why they put 5.50. So I'm guessing you have to put the 0 at the end. But I understand where you're coming from. I totally understand where you're coming from. But putting the 0 at the start, I'm not too sure. they might have an argument about that in the examiners. But I almost positive this point, because normally they will put like 5.5, but you see they include that 0 there. I feel that's a reason. Yeah. Yeah, they put that for a reason. Yeah, I'll stick with my answer because more than likely that is what they want you to do with the 0. But yeah, some students may do what you did with the 4 for the exponent. And let's put 1, 0, 0 for the exponent. Hold on, let me just Google something real quick. 5.50 using SEM. Gosh, work or I'll Google it right now. Yeah. Right. Yeah, we'll stick with this answer. That thing with the 4-bit the exponent being 4. Yeah. I don't want to believe, because based on normal calculations for SCM, you'll have a 5-bit answer and you put the 0 in front. I'll ask another teacher what they would do, but more than likely they might have to accept both, depending on where you put it. But all right, 8-bit 2's complement of -11, so let's go with 11 in binary is 8 plus 4, no, 8 plus 4 is 12, 8 plus 2 is 10, plus 1 is 11, right? So that's 11. But it's 8 bits, so you had to drop a lot of zeros in front of it. Okay. It will be 0, 0, 0, 0, 1, 0, 1, 1, because it's 8 bits, right? 8 bits, then we have to invert 1, 1, 1, 1, 0, 1, 0, 0. After you invert, then you have to add 1, boom, add 1, 0, 1, 0, 1, 0, 1, 1, 1, 1. And that's the uncle, Bob's the uncle. Negative 11. I mean, you could easily check that. You could check that all over. But 2's complement, that's key. That's thing. Alright, so far the only weird one is this party here. If you put the 0 at the start or you put it at the end. I believe the 0 is at the end because it's 5.50. And they want you to account for that. So, cake, diabetes, one little circuit diagram, and we're moving on.